So yesterday in the previous video we have done problems on Newton's forward interpolation formula. So Newton's forward interpolation formula, again I am repeating, should be used when the values of x are spaced in equal intervals and the value of y is required at the beginning of the table. Now I am telling you a new formula called Newton's backward interpolation formula, which should be used when the values of value of y is required at the end of the table, and same as previous method, the value of x is are spaced in equal intervals. So this is Newton's backward interpolation formula. I'll just write it. Y of x is equal to yn p by factorial 1 into del yn plus p into p plus 1 by factorial 2 into del square yn plus p into p plus 1 into p plus 2 by factorial 3 del cube yn plus so on. When I do the problem, you'll understand how to do the problems, where p is equal to x minus xn divided by h. H is the difference between any two successive x values, same as forward difference problems. So again I am telling you, Newton's backward formula should be used when the values of x are spaced in equal intervals and the value of y is required at the ending of the table. So I'll explain this thing again when I do the problem. So first problem, find the value of y when x equal to 105. X values, x is 80, y value is 5026. X is 85, y is 5674. X is 90, y value is 6362. X is 95, y value is 7088. X is 100, y value is 7854. Now, if you take, this is the beginning of the table and this is the ending of the table, you are supposed to find the value of y at x equal to 105. 105 comes after 100. So we use here backward formula. Forward formula cannot be used. So you can use this formula to find the value of y when x is equal to 97. 97 comes between 95 and 100. You can assume it is towards the ending of the table. If you take this as the beginning and this is the ending. Okay, again see the values of x: 80, 85, 90, 95 and 100. Yesterday I told you in the previous video how to find h value. H is the difference between any two successive x values, 85 minus 85 or 90 minus 85, 5. So h we take it as 5. And remember, again I am telling you, Newton's forward or backward formula should be used only when the values of x are spaced in equal intervals. You need not worry about y values. There are some other formulas called as Lagrange's and Newton's general formula, which you can use when the values of x are spaced in unequal intervals. Okay, now we'll do this problem. Again, you have to find the value of y when x is equal to 105. First, as before, we find the difference table. Right. Here, I have found the difference table. Instead of calling it as forward difference table, I'll call it as backward difference table. Only the name change, procedure is same. So he has given us x values, y values, I have listed them here. Instead of calling, when you are using Newton's backward formula, instead of calling these as delta, delta square, we'll call them as del, del square, del cube, del power 4. Same procedure how to find this minus this. I have written here. This minus this, we write it here. This minus this, we write it here. This minus this, I have written here. These are called first order backward differences. Next, del square I am finding. This minus this. 688 minus 648, 40. 726 minus 688, I have written here 38. 766 minus 726, 40. Next, third order differences. This minus this, 38 minus 40 minus 2. 40 minus 38, 2. Next, finally, delta power 4. 2 minus of minus 2 plus 2, 4. So that's all. This is called backward difference table. Now I have written here Newton's backward difference formula. Y of x is equal to, I have written here. First you have to calculate p value. So before going to calculate p value, whenever you are using Newton's backward difference formula, first make it a point, underline the last values in the table. See how I am doing it. The last value under x, you take it as xn. The last value under y, you take it as yn. The last value under del, take it as del yn. The last value under del square, take it as del square yn. Last value under del cube, take it as del cube yn. Last value, there is only one value, so take it as del power 4 yn. Now I have written here Newton's backward formula, same what I have told. Y of x equal to yn plus p by factorial 1 del yn plus p into p plus 1 by factorial 2 del square y, and so on. Same formula written. First calculate p, x minus xn by h. X will be given in the problem. He says find the value of y when x equal to 105 or some other thing. So he has asked in the problem. So I am taking x as 105. Xn, what I told you, the last value under x, that is 100. I have written here. Then h value, difference between two x values, 85 minus 85, I have put here. So when you calculate 105 minus 100 by 5, 5 by 5 equal to 1. This is the value of p. So for backward and forward formula, the formula for p will change. So y at 105 equal to yn. What is yn? Last value under y, 7854, I have written here, plus formula you see, p is 1 by factorial 1 is 1, 1 by 1 is 1 into del yn, last value under del 766, I have written here, plus p into p plus 1, p is 1, 1 into 1 plus 1 by factorial 2, factorial 2 is 2 into del square yn 40 plus p into p plus 1 into p plus 2 by factorial 3, 6 into del cube yn is 2 plus last p into p plus 1 into p plus 2 into p plus 3 by factorial 4, factorial 4 is 24 into del power 4 yn from the table, it is 4. I have written. So when you calculate everything, the answer is 8666. So I have written it. This is the first problem. Next. Right. Find tan 0.26 from the following table of values. He has given x and tan x. So x is 0.1, tan x is 0.1003. I think he has taken these values of tan x, keeping the calculator in radians. X equal to 0.15, tan x is 0.1511, x is 0.2, tan x is given 0.2027, x is 0.25, tan x is 0.2553, x is 0.3, tan x is 0.3093. We have to find tan of 0.26. That means if you take y as tan x, you have to find the value of y when x is equal to 0.26. Now again, This is the table of values. If you take this as the beginning of the table, this is the ending of the table. 0.26 will come between 0.25 and zero point 0.3 towards the end of the table. So we cannot use forward formula. So we are using backward interpolation formula. So I am prepared backward difference table. Right. X, whatever he has given, y, tan x values, I have written here. X is 0.1, okay, whatever he has given, here I have written. Next, del, how to calculate. First order backward differences, they are called. Simple, same as the forward difference table only. 0.51511 minus 0.1003, I have written here. 0.2027 minus 0.1511, I have written here. 0.2553 minus 0.2027, I have written here. 0.3093 minus 0.2553, last word. Next, del square. This minus this, I have written here. Next, this minus this, I have written here. 0.540 minus 0.05, 0.0540 minus 0.0526, I have written here. Next, this minus this, I have written here. 0.0014 minus 0.001, I have written here. Lastly, 0.304 minus 0.302, you get this. So this is backward difference table. So 0.26 comes towards the end of the table. So I am using Newton's backward formula. First, whenever you use forward difference table, yesterday I told you, last video, you underline the first values. For backward differences, underline all the last values first. So what is the last value under x? It is xn. What is the last value under y? Yn. What is the last value under del? Del yn. What is the last value under del square? Del square yn. Under del cube, it is del cube yn. There is only one value here, del power 4 yn. Now, first we shall calculate, okay, I have written the formula here. Y of x equal to yn plus p. Okay, now you know this. P equal to x minus xn by h. So x, he has asked you to find tan 0.26, or other words, y at 0.26. So 0.26 is x. Next, xn, last value under x, 0.3 divided by h, very important. Difference between two x values, 0.15 minus 0.5, successive x values is 0.05. So h is 0.05. P I have calculated, x minus xn by h, we get minus 0.8. Now tan 0.26 or y at 0.26 equal to, I am using this formula, yn 0.093, last value under y. Right. Next, p minus 0.8 by factorial 1 is 1 into del yn, last value under del 0.054, I have written it, plus p into p plus 1, p is minus 0.8 into p plus 1 by factorial 2, that is 2, into del cube yn 0.004 under del cube, plus finally sorry, this is del square yn. Third, p into p plus 1 into p plus 2 by factorial 3, this is del cube yn, last value under del cube, plus p into p plus 1 into p plus 2 by, okay, this already I told, p into p plus 1 into p plus 2 into p plus 3 by factorial 4, 24, into del power 4 yn. This is del power 4 yn. So when you calculate, you get the answer as 0.2660. You can verify your answers. Keep the calculator in radians. Only such problems you can verify. You see what is tan 0.26. Almost same answer you get. Okay. So today already have uploaded assignments on backward and forward formula. Please first read the notes, try the worked examples, whatever I have done, the two problems. Try by yourself, verify your answers, then do the assignment and submit the assignment by 8th of April. Right, thank you.